Okay, so this is then the Year 8 Metals and Acids Knowledge Test. Right, so this is pretty much all the answers that you're going to need to absolutely smash the Year 8 Knowledge Test on metals and acids. Plan an investigation to compare the activity of 4 metals using hydrochloric acid. So first step is add the metal to, I'm going to put down HCl, which is the hydrochloric acid. You could collect the gas, you could observe the number of bubbles, you could time for the reaction to stop, okay. Now, when you're actually doing this, what you're actually doing, if I just do it in red here, is you've got your test tube, you've got acid in it, and then you put your piece of metal in it, right? Now, a number of things that you just need to remember on this is that you've got to use the same size piece of metal, you've got to use the same amount of acid each individual time, and then you need to decide on exactly how you're going to collect, observe, or time the reaction to stop. You're just going to have to do one of them. Okay, now it's up to you then what you've got to do, right? But they're kind of your options. When you've done it the first one, what you then do is you repeat it for the other metals. Okay, and if you've got 4 metals, then you just need to keep on repeating it. If we think about the variables, right, we've got the dependent, we've got the don't mess independent, and we've got the control. Okay, right, so if I just go on to, let's go green, I always remember it as don't mess in class, stay calm. So don't mess, dependent is what you're measuring during the actual practical itself. So it could be the bubbles, or it could be your counting. Don't mess, so dependent is measure what you're measuring during the practical. Independent is then what you change between practicals, is then the metal. And the control, so dependent, measure, independent, change, stay calm means control stays the same. So size of metal, the amount of hydrochloric acid, the temperature, any of those are the things that then could come into it. And what you need to do on a question like that is you need to kind of just clarify it, and even though I've given you kind of the crux of what's actually going on with it, you then need to kind of formulate it into a proper kind of sentences that make sense in your head. Question number 3, list out the reactivity series and 12 elements. Okay, so I think there's only 11 elements on it. So what we're going to do is I'm going to go, please stop calling me a cute zebra in chemistry study group. Okay, and then that's just kind of a way of trying to remember it. So if I then do these into red, so please is potassium, which is K. Stop, which is sodium, which is Na. Calling is calcium, which is Ca. So we've got the S for sodium, we've got the P for potassium, we've got the Ca for calcium. Me is magnesium. A is aluminium. A, M. Cute is carbon. And then we've got zebra, which is the most obvious one, which is Zn. In is iron, which is Fe. Chemistry, Cu for copper. Study is Ag. And group, so that's then for silver. And then group is then Au, which is gold. Okay. I think on this PowerPoint then, right, I was just thinking about it then, right, I think question number 2 was missed off. Right, so question number 2 was missed off. It was how would you test for hydrogen gas? It is a lit splint. Right? If you put a lit splint into hydrogen, what you do is you get a squeaky pop. Okay, I would try and make the noise, right, but there's not a chance. Question number 4, what is a displacement reaction? It is where one metal displaces in a reaction another. Another. Right, so a more reactive metal displaces another. So if you think about the reactivity series we just had, if you've got a reaction between sodium and calcium, because sodium is more reactive, it will displace calcium in a reaction itself. Right, so this is then a typical example of it. Okay, so what we'll have here is we've got copper and we've got iron. The most reactive, right, is iron. So what will happen is you'll get iron sulfate, because what's happened is the iron has battered the copper, and then you'll have copper left on its own. Now we've got zinc sulfate and iron sulfate and zinc. Right, what happens this time? Because zinc is more reactive, it then becomes zinc sulfate plus iron. Right, and these are displacement reactions where the more reactive displaces the other metal. Sodium sulfate and magnesium, nothing. Right, nothing happens there because sodium is more reactive, so sodium stays in the reaction itself. Question number 6, name 2 metals that can be extracted from their oxides using carbon. Okay, so 2 metals, right, we could have zinc oxide and we could have iron oxide. Now the reason why I'm choosing those 2 is because they are below carbon in the reactivity series. And what we do is we react them with carbon and we make carbon dioxide plus zinc, and we make carbon dioxide plus iron. Right, because the carbon being more reactive than zinc and iron displaces them. Describe how you would separate sodium chloride. Right, so sodium chloride, because sodium is more reactive than carbon, you can't use carbon to separate out the sodium. So what you have to do is, I'm going to just do a very, very rough drawing of it. Right, you have to put 2 electrodes, positive and a negative, into your solution, and this process is called electrolysis. So plan a method to extract copper from copper oxide. Right, so what I'm going to do is I'm going to write down copper oxide at the top because copper oxide is black, and I'm going to react it with sulfuric acid. Okay, so those 2 then react together. When you get the reaction, what you then do is you make copper sulfate. Okay, now the reason why I've done that in blue is because that's what colour copper sulfate is. Then, to actually extract the copper, we then have to do the process I talked about before, which was electrolysis. Keywords. A rock that you can extract from metal, an ore, right? And that means financially viable, which means there's enough metal in it that it's worth the actual process. A list of metals in order how vigorously they react is the reactivity series. State symbol, solid, liquid, gas, aqueous, means dissolved in water. And then the final one is a reaction of aluminium with iron oxide to make aluminium oxide and iron. It's called the thermite reaction. Now, in that one, right, there's a lot of learning, right, because it'd be a very good idea to learn the reactivity series. Now, I haven't gone into very much detail about electrolysis, right, but electrolysis comes up loads in year 10 and 11, right? So what you could do is you could go away and you could try and understand exactly what's going on with this piece of equipment with the positives and the negatives, all right? And if you can get that now, then that's absolutely fantastic. Once you've done this test, go to the blank one, pause it, write down your answers onto the sheet.